Welcome to Ask Engineering Academy. Today I would like to explain about Ecet examination 2025 Telangana and Andhra Pradesh people, engineering chemistry, acids and bases. Acids and bases. Before going to the topic, I would like to introduce about this institution. Ask Engineering Academy established in Dilsukhnagar near Satyanarayana Swami temple. If you have any doubts, you can contact directly to the institute, or also available Google Play Store this institution app, and also download the app, and you can listen the online classes, recorded videos also. Okay. If you require online classes, you can download the Ask Engineering Academy app from Google Play Store and listen the classes. If someone need offline also, you can contact to the institution directly at Dilsukhnagar. Okay, all the best. Now I would like to introduce what more acids and bases unit. Acids and bases unit. Acids and bases, what is the syllabus it contains? Introduction, theories of acids and bases and limitations, Arrhenius theory, Bronsted-Lowry theory, Lewis acid base theory, ionic product of water, pH and related numerical problems, buffer solutions, buffer action and applications of buffer solution, and last one, Ostwald's theory of indicators. Ostwald theory of indicators. Next, I am going to introduce one by one the introduction of acid bases. Introduction of acid bases. Here, most probably the chemical substances are going to divided acids, bases and salts. Acids, bases and salts. Now I would like to introduce what are the properties of acids. Acid behave taste, which is a sour taste, which is a sour to taste. Here litmus paper turns blue litmus to red litmus. Whatever the acidic substances, litmus paper is going to turn into red, and pH value is less than 7. Whatever the acids, the pH value is less than 7. And chemical reaction, what happen? Releases hydrogen ions. Releases hydrogen ions H plus when dissolves in water. Whatever the acidic substances, whenever dissolve in water, which releases H plus ion, these are the basic properties of what acids. Now I am going to properties of bases. Properties of bases which are bitter to taste, which are what bitter to taste and feel slippery, which is going to what slippery, and litmus paper turns red litmus to blue litmus. Here what exactly opposite to what acids. Acids, they converts blue litmus to red litmus, but in bases litmus paper turns red to blue, red to blue. Okay. Here what happen? pH greater than pH 7, which means greater than 7 means more than 7. Whatever the chemical substances are behave basic substances. Here chemical reactions releases hydroxides whenever dissolves in water. Here what more? Whenever basic substances are going to dissolve in water, they release OH minus. They release OH minus. This is the introduction of acids and bases. Next we have theories of acids and bases and its limitations. Theories of acids and bases and limitations. Here check it. What are the different theories of acids and bases? Here we have total 3 theories: Arrhenius theory, Bronsted-Lowry theory and Lewis theory. Arrhenius theory, Bronsted-Lowry theory and Lewis theory. Here one by one I would like to introduce the definition of acids and bases. Arrhenius theory, just 3 theories definitions I am giving here, and then after I would like to explain one by one separately different theories. Hydrogen ion H plus donor. H plus donor, whatever the substance which donate H plus, that is treated as what acid. HCl is hydrochloric acid. HCl is belongs to acid, an example. Hydroxide, Here what OH minus ion donor. OH minus ion donor is said to be what base according to Arrhenius. This according to Arrhenius. Next we have according to Bronsted-Lowry theory, proton donor is an acid. Proton donor is an acid and proton acceptor is a base. Proton acceptor is a base. Proton donor is an acid means what is example? H2O. H2O water. H2O will give H plus easily. H2O it can act as what more? An acid. Here proton acceptor. Whenever proton acceptor to the other chemical compounds, other chemical substances which is said to be what more? Base. NH3. NH3 will accept easily proton towards itself. Here NH3 can act as what more? Proton acceptor. Then it is said to be what more? Base according to Bronsted-Lowry. Next Lewis theory. Here next Lewis theory, electron pair acceptor is an acid. Electron pair means a couple of electrons can accept towards itself. That is said to be what more? Lewis acid. Example what more? Electron pair acceptor. Here example carbon dioxide. Electron pair acceptor. And electron pair donor. Electron pair donor is an what more? Base. Electron pair donor is a base. Electron pair donor is a base. Whatever the compounds that are ready to donate electron pair, that is said to be what more? According to Lewis, it is a base. It is a base. Finally, I am concluding. Electron pair acceptor is an acid, electron pair donor is a base. Okay, these three theories, after one by one I would like to explain theories. Check it. Arrhenius theory of acids and bases. Arrhenius theory of acids and bases. Here acid. What is the definition of acid? A substance which gives H plus ion in aqueous medium. A substance which gives H plus ion in aqueous medium or solution is called an acid. What is the definition? Once again I am repeating, a substance which gives H plus ion in aqueous solution is called an acid. Next I am going to introduce base. A substance which gives OH minus ions in aqueous solution is called base. A substance which gives OH minus ions in aqueous solution is called a base. Here what are examples you can see here? Acid examples: hydrochloric acid, H2SO4, HNO3, etc. are examples of acids. Here what are basis examples? Sodium hydroxide, potassium hydroxide, calcium hydroxide, etc. are belongs to basis examples. Here whenever this hydrochloric acid dissolves in water, which will give H plus and Cl minus, H plus will give, it is treated as an acid. Whenever the sodium hydroxide is going to dissolve in aqueous solution, which means water, it dissociates into Na plus and OH minus. Na plus and OH minus, it is also release OH minus. That's why this compound is treated as base. Here next we have in this neutralization. You can see here, acid combined with base to produce salt and water is called neutralization. acid reacts with base, acid reacts with base to form salt and water. Salt and water is called neutralization. How they form neutralization reaction? You can say HCl plus NaOH. HCl is an acid, NaOH is a base. These two whenever combined to produce NaCl plus H2O. What is this? Acid. What is this? Base. This is salt. This is water. Acid reacts with base to form salt and water is called what more? Neutralization. Acid combined with the base to produce salt and water. Salt and water is said to be what more? Neutralization. This is what more about Arrhenius theory. Acid definition, base definition and neutralization. What are its limitations? Here check it. Here limitations of Arrhenius theory. Here this theory cannot explain the compounds which are not having H plus and not having OH minus. The compounds, the chemical compound which are present, which are not having OH minus and H plus. He did not say which is an acid or which is a base. Compulsory what is taking? H plus is given, it is an acid. OH minus is given, it is a base. But other than H plus and OH minus, here only whenever present H plus and OH minus only Arrhenius discussed it is an acid, it is a base. Other than this H plus and OH minus, some compounds are behave acidic or basic, he did not say. Here what more like this? What more? Other than hydrogen, carbon dioxide can act as an acid. Carbon dioxide can act as an acid, and also calcium oxide and magnesium oxide can act as what more? Basic substances. These are the major limitations here. What more? The compounds which are not having H plus, it does not explain it is an acid or base. The compounds which are not having OH minus like calcium oxide and magnesium oxide etc. behave like a basic nature. Also he did not explain according to this theory. This is the major information about Arrhenius theory. Okay students, next I would like to continue next theory, Bronsted-Lowry theory. Here according to Bronsted-Lowry theory also I am going to discuss about acid and base etc. Here according to Bronsted-Lowry theory, what is an acid? Here I am giving acid. A proton donor, proton means what more? H plus. A proton donor is an acid. A proton donor is an acid. That is acid definition. Next base definition. A proton acceptor. A proton acceptor is a base. A proton acceptor is a base. Here check it more. Clearly I am giving. This theory is also called as proton theory. A proton donor is an acid. A proton acceptor is a base. Here I am giving the examples. You can check it carefully. HCl combined with water molecule. Reversible arrow mark. Here this hydrochloric acid donate proton to water molecule. Here what is going on? this hydrochloric acid, H plus donates to this water molecule, which means this hydrogen is going to convert into H3O plus hydronium ion and Cl minus. Cl minus. It is what more? Acid 1. It is also called what more? Acid 2. It is also called what? Base 1. It is also called what more? Base 2. Here this is an example of what more? Acid which donate proton to H2O. This is called what more? Base. Here this is called what more? Acid 2. This is also called as what more? Base 2. Here very important point is there here. For exam point of view, very important. What is conjugate acid base pair? What is conjugate acid base pair? Conjugate acid base pair. Number of times this question is given. Which of the following is conjugate acid base pair? Here what is conjugate acid base pair means? A single proton differ between them is called what more? Conjugate acid base pair. A single proton differ between them. A single proton differ between them is called conjugate acid base pair. Conjugate acid base pair. Okay. Here what is conjugate acid base pair? Here I am writing examples. Here check it. HCl comma Cl minus. How many protons are differ? Only the single proton differ. Observe these two pair, hydrochloric acid and Cl minus ion. Here only one proton differ in between them. It is called what more? Conjugate acid base pair. And one more also I am writing H2SO4 comma HSO4. In between these two also we can observe. Here hydrogens 2, here hydrogen 1. How many protons differ in between them means only one hydrogen, one proton is going to differ between them. Then it is said also conjugate acid base pair. Conjugate acid base pair. You simply remember what is conjugate acid base means. At what is conjugate acid base pair means, here in between one single proton is differ, that is said to be what more? Conjugate acid base pair. Understood my point here? Here what more? Only single proton. If two protons differ, three protons differ, that is not a conjugate acid base pair. Only single proton. Here I clearly mentioned single proton differ, then it is said to be what more? Conjugate acid base pair. Conjugate acid base pair. Here according to Brownstein-Lowry theory also, what is not explained compulsory, whenever proton donate, that is said to be an acid. Whenever proton acceptor, that is said to be base. Here also not explained what the chemical compounds which are not donating proton, also few compounds can act as anode. The chemical compounds which do not accept proton also they can act as a base. That also here not explained. Means limitations. He is not explained whenever proton donor and proton acceptor is not present. Whenever a chemical compound cannot give any proton and cannot accept any proton, that type of compounds he did not discuss anything. Simply he explained only whenever proton donates, that is an acid. Whenever proton accept, that is said to be base. But the compounds which are not having proton, he did not discuss anything. Like for example, carbon dioxide can act as an acid. CO2 can act as what more? Acts as acid. But in this theory cannot explain, and also CaO, MgO can act as a basis and also cannot explain in this, and also cannot explain according to this theory also he cannot explain carbon dioxide is an acid practically, but according to this theory he did not explain calcium oxide and magnesium oxide are bases practically, but according to this theory he did not explain anything about these compounds. Okay, these are the limitations of what Brownstein-Lowry theory. Next I am going to continue next theory, Lewis theory. Listen ma, electron here this theory is described about electron pair. Here what is acid definition, here I am writing, and what is base, here also I am writing. Electron pair acceptor is an acid. Here what ma, electron pair acceptor. Electron pair acceptor is an acid. Electron pair acceptor is an acid. Electron pair acceptor is an acid. S, electron pair acceptor is an acid. What are examples? BF3, AlCl3 etc. are said to be what ma? According to Lewis, acid. According to Lewis, what is the base definition? Lewis base, electron pair donor. Electron pair donor. Electron pair donor is a base. Electron pair donor means a couple of electron which can donate to other compound. Whatever the compound donates that 2 electron, that compound is said to be what ma? Base. Here examples, H2O, NH3 etc. is said to be what ma? It's said to be what ma? Lewis base. Once again I am repeating, what is Lewis acid? Electron pair acceptor is an acid. BF3, AlCl3 is an examples. What is according to base? Lewis base, electron pair donor is a base. Electron pair donor is a base. Example, H2O. This compound you can easily identify how this electron pair donor H2O have 2 lone pairs on oxygen atom and nitrogen also having 1 lone pair on nitrogen atom. These lone pairs are ready to donate to other compound. This compound can act as a base. Whatever the compound accept that lone pairs, that compound can act as what ma? Lewis acid. Lewis acid. Here what happened? Neutralization what happened? Check it. Here whenever H plus is going to react with water molecule, what happened? They form H2O. They form H2O. Here H plus, no electron. Electron deficient compounds are can act as what ma? Lewis acid. Here lone pair is there. Lone pair is there. This lone pair is going to, here empty orbital is there. This lone pair is going to transfer towards this H plus. This H plus. I am writing, just a minute. This one I am writing exact. Here H2O is going to combine with H plus, here having lone pair, empty box, empty orbital. This lone pair is going to donate to this hydrogen. Here what is going to form? H2O. H2O is formed like this bond H plus. H2O is going to form like this one H plus or H3O plus, which is said to be what more? Hydronium. Hydronium ion. Hydronium ion. Understood here? This lone pair donates to this H plus. Here H plus do not having any electron. Whatever lone pair donates, that lone pair is accepting, means it is an acid. It is a base. H2O is a base. H plus is an what more? This is a base. This is acid. Here finally to get what more? This bond is said to be what more? Coordinate covalent bond. Coordinate covalent bond. What is coordinate covalent bond? Any one of the atom can donate bond formation electron is said to be what more? Coordinate covalent bond. Bond formation electron, any one of the atom can donate. This is called what more? Coordinate covalent bond. Coordinate covalent bond. This is neutralization. And one more examples also you can write here. NH3. NH3, ammonia having one lone pair, and also boron trifluoride you can combine. Boron trifluoride also one empty p orbital they have. Here this lone pair is going to transfer to this empty orbital. What's happened in between NH3 and BF3? Coordinate covalent bond is going to form. Coordinate covalent bond is formed. This is what more? Whenever in between one arrow mark bond is written, that indicates coordinate covalent bond. Coordinate covalent bond. This is about Lewis acid theory. Lewis acid theory. Here again we have types of, just I am introducing types of Lewis acids. Types of Lewis acids is simply what more? All cations, all simple cations are said to be what for Lewis acids. Lewis acids, the compounds which are not obtain octet rule, not following what more? Octet rule, that is also treated as what more? Lewis acids. The compounds which are octet rule expands, octet rule expands, that is also treated as Lewis acids. These are the Lewis acids. Next we have here all cations. All cations are said to be what more? Lewis acids. And also the compounds which are not obtain octet rule, not having octet rule, that is also treated as what more? Lewis acids, like BF3, AlCl3, etc. And the compounds which are going to expand its octet rule, that is also said to be what more? SiF4, SiF4, SiCl4, etc. or belongs to what more? Types of Lewis acids. Types of Lewis acids. Next we have types of Lewis bases. Here I am writing types of Lewis bases. Types of Lewis bases. Simple anions. Simple anions are treated as what more? Lewis bases. And the compounds which are having lone pair, compounds which are having lone pair, that is also Lewis acids. Compounds which are having lone pairs, that also Lewis acids. Examples, here you can write H2O, NH3, NH3, etc. or belongs to Lewis acids. Simple anions means the compounds which are having minus charge. Anion means what more? The compound which are having minus charge, which is called anions. All simple anions are said to be what more? Lewis bases. This information about what more? Lewis acid base theory. Lewis acid base theory. Next I would like to continue next topic. Here now I would like to discuss a sample question for Ecet examination Telangana and Andhra Pradesh. Listen this question. What is question given? The compound that does not act as a Lewis acid. Just now I completed Arrhenius theory, Brownstein-Lowry theory and Lewis theory. Three theories are completed. After the completion of these theories, here one question I would like to discuss with you. The compound that does not act as Lewis acid. Lewis acid. Lewis acid means what I gave last theory I discussed. Proton electron pair acceptor is an acid. Here what more? Lewis acid means, here I am writing the definition. Lewis acid means what more? Electron pair acceptor. Lewis acid means what more? Electron pair acceptor. Okay. Here given example one by one you can check it. Given example here one by one you can check it. Here barium chloride is given. Barium chloride, aluminium chloride, AlCl2, BF3 and BeCl2. These are all electron deficient compounds. Electron deficient compounds are ready to accept electron pair. Just now only I said electron deficient compounds get ready to accept electron pair. Here only not electron deficient compound. This is the right option for given question. Barium chloride is the correct answer given question. The compound that does not act as Lewis acid. These are all Lewis acid. This is electron deficient compound. This is also electron deficient compounds. This is also electron deficient compound. You can check it. How can you decide which is not electron deficient, which is electron deficient compound means? You can check it. The compounds which are not following octet rule, that is Lewis acid Lewis acid. Check it one. AlCl3, AlCl2 is given. AlCl2 is given. Like you can take an example. Chlorine belongs to 7th group. They have total number of electrons like this. Here what now? Chlorine having total number of electrons 7. Here aluminium belongs to 3rd group. Here they form like this. AlCl3. This one. Here AlCl3. Electron deficient is there. Here bond is formed. Here bond is formed. Here bond is formed. One more electron is also is there here. But this is also electron deficient. And one more BF3 also is there. BF3 boron 5th group. Here BF3 means 3 fluorines. You can write like this. Fluorine. Fluorine belongs to here 7th group. You can write like this. 7th group means 7 electrons. You can write. Boron 3rd group 3 electrons. You can write. 3 electrons. Here 7 electrons every fluorine. 7th group means here in between one bond form, in between one bond form, in between one bond form. Means this bond 2 electron, this bond 2 electron, this bond 2 electron. Here octet is not filled. Octet means what more? Octet means what? OCTET. Octet means 8 electrons around the atom. 8 electrons around the atom. Check it. Here AlCl2 means what more? One bond is formed, one bond is formed. Total number of electrons 4. This one 1 electron. Total 4 plus 1. Only here 5 electrons are there. Only 5 electrons are there. Here only 6 electrons are there. And one more example also you can see. BeCl2. Cl. Beryllium is belongs to 2nd group. Here 1 electron, here 1 electron you can write. Chlorine 7th group. Total 7 electrons to be present. Here in between bond form, only 2 plus 2, 4 electrons only is there, 4 electrons, 4 electron. And here barium, check it now, and also what is the correct option, that is also I am explaining. Barium and 2 chlorines you can write, 2 chlorines you can write. Barium chloride, which is not acts as what more, Lewis acid. Lewis acid does not act as Lewis acid. 2 electron, 2 electron, 2 electron. Here 2 electron, 2 electron, 2 electron, one single electron. Here barium, what is its configuration? It belongs to what more, to group element. Here to form barium chloride. Barium chloride to produce what more, octet rule. Here this is the right option to come. What more, the compound that does not act as Lewis acid mean, which is only not what more, electron deficient compound, not a electron deficient compound. Here this is the right option. All these three what more, Lewis acids only. Lewis acid. Lewis acid. This is also Lewis acid. Only barium chloride is acts as what more here, not Lewis acid. This is one sample question. Next, one more question also is given. You can see, which of the following is largely responsible for the acid rains? Which of the following is largely responsible for the acid rains means, here carbon dioxide and carbon monoxide and carbon dioxide is not responsible, nitrogen oxide and nitrogen dioxide. Here what is right option means, this is belongs to especially environmental studies topic, but here came this question. Now you listen, sulfur dioxide and nitrogen dioxide is majorly lot of responsible acid rains. Sulfur dioxide and nitrogen oxide, whenever present in the environment, they form sulfur trioxide and nitrogen acids are formed. Nitrogen oxides and sulfur oxides are going to form. These are what more? These are causes majorly acid rains, sulfur dioxide and nitrogen dioxides. Next I am going to discuss about ionic product of water. What is meant by ionic product of water? Everybody know water is a natural source. Its chemical formula also H2O, everybody knows. How to dissociate this H2O? H2O is dissociates as H plus and OH minus. Okay, everybody know this water molecule H2O is going to dissociate into H plus OH minus. Here what is ionic product of water? Definition. Here listen more definition. The product of H plus and OH minus ion concentration is said to be what more? Ionic product of water. These are ions. This is what more? Cation. This is what? Anion. Combinedly called as what more? Ions. Here combinedly called as what more? Ions. Combinedly it is called ions. Positive cation, negative anion. Here what did I say? The product of H plus and OH minus ion concentration. The product of H plus and OH minus ion concentration is said to be what more? Ionic product of water. Ionic product is going to denoted by Kw. Kw. What I say? A product of H plus and OH minus ion concentration. Concentration always should be written like this square bracket, H plus concentration, OH minus concentration. Kw is equals to, what is this? H plus and OH minus ion is a concentration of H plus and OH minus. It is the product of H plus and OH minus ion concentration is said to be what more? Ionic product of water. Ionic product of water. If you want to calculate H plus, what is equation to come? H plus is equals to, concentration of H plus is equals to Kw by OH minus concentration, one equation. If you want one more, OH minus you need concentration of OH minus whenever required to get Kw divided by H plus equation you can use. Okay, here what is the ionic product of water? Ionic product, what is exact value? Kw. Kw value, what more? Especially here H plus concentration here I am giving 1.0 into 10 to the power of minus 7 moles per liter, and also OH minus concentration also equal same 1.0 this 1.0 into 10 power minus 7 moles per liter. These two values you can substitute in this equation. This equation, what is the value to come? Kw is equals to 1.0 into 10 power minus 7 into one more 1.0 into 10 power minus 7. What are the units? Mole per liter, what is coming? Moles square per liter square. Here what is the value to come final whenever multiply with 1.0 into 10 to the power of minus 14 moles square per liter square. That is Kw of water. Here why here written only W means water molecule, Kw of water. If in case any other chemical if you are using Kw of that chemical, first letter you can write Kw. Kw means equilibrium constant of what more? Water is equals to what more? 1.0 into 10 to the power of minus 14 mole square per liter square. This is about ionic product of water. Ionic product of water. In your examination point of view, the possible question Kw value, already this practical value this. Any OH minus concentration may be given, they are asking H plus ion concentration, what is that? And whenever given H plus ion concentration, Kw using and OH minus ion concentration calculation, etc. concepts to come in the examination. Okay. After this, next pH related numericals, and what is the pH definition and what is pH related numerical, etc. I am going to discuss with you. Here pH, what is the definition? pH is first invented by Sorensen. What is its definition? The negative logarithm of H plus ion concentration is said to be what more? pH. Here I am writing pH is equals to minus log to the base 10 H plus concentration. pH is equals to minus log to the base 10 H plus ion. What I say definition exactly I am writing here the equation. The negative logarithm of H plus ion concentration is said to be what more? pH. Here check it. The pH scale is a convenient way to represent the acidity or basicity of a solution. We can calculate the pH of solution by taking the negative logarithm of the hydronium ion concentration, or pH is equals to log of H3O plus also. pH is equals to what more? Is equals to negative logarithm of H3O plus also is written. This is basic equation, and also modified. What is that? pH is equals to minus log of H3O plus also pH equation. Here few pH scale I am giving in between pH what more 1 to 7 what more, what are the chemical substances acts as acidic nature. The pH value is 7, that compounds are acts as neutral. The pH in between 8 to 14 this especially these compounds are behaving as a basic nature. Here what more? pH less than 7 acidic, pH is equals to 7 neutral, pH greater than 7 basic. This basic information, what I say, pH definition, and in between 1 to 14 are different types of acidic or neutral or basic substances, I say. Once again I am repeating, negative logarithm of H plus ion concentration is said to be pH. pH less than 7 acidic solution, pH is equals to 7 neutral solution, pH greater than 7 basic solution. Okay, here few pH scale what are given, check it. Here pH value should be 0, pH value should be 0. Here especially battery case water, whatever the distilled water we are using, that water do not have any pH, battery acid. Whatever the battery acid which are going to use, that battery acid do not contain any pH value, it should be 0. Here gastric acid pH value 1, lemon juice pH value 2, and apple juice pH value 3, tomato juice pH value 4, black coffee pH value 5, and milk also acts as acidic nature, pH value 6, and water, water can act as neutral, it exhibit it equal to pH value 7, egg it is acts as a base, pH value 8, and baking soda pH value 9, milk of magnesia pH value 10, ammonia solution pH value 11, and soap, whatever they nowadays soaps are using, that pH of that soaps pH value is 12, bleach pH value is 13, drain cleaner what pH value is 14. Orally what you remember, pH value less than 7 acidic, pH value equal to 7 neutral, pH value greater than 7 basic substances. After that we have next continuation, buffer solution. What are buffer solution? A mixture of solution which resists its pH value, a mixture of solution which resists its pH value, it means maintain constant pH value whenever a little amount of acid or base to add to it. Once again I am repeating, a mixture of solution which resists its pH means by maintaining constant pH value whenever addition of little amount of an acid or base also keeps maintain constant pH value, that is said to be what buffer solution. Here buffer solutions are two types types of buffer solutions. Here we have acid buffer solution. Acid buffer solution means, listen more, a mixture of weak acid and strong base. A mixture of weak acid and strong base. A mixture of weak acid. A mixture of weak acid and strong base. A mixture of weak acid and strong base is said to be what acidic buffer. Example, acetic acid CH3COOH plus CH3COONA. It is an example. Next, second one, base buffer solution. Base buffer solutions. Base buffer solutions. Base buffer solutions. A mixture of weak base and strong acid. A mixture of weak base and strong acid is said to be what buffer solution. Here example, ammonium hydroxide plus ammonium chloride. In this, ammonium hydroxide is weak base, ammonium chloride is strong acid. Here acetic acid is weak acid and sodium acetate can act as what strong base. This is about what types of buffer solutions. Here buffer action, buffer solutions, whenever addition of OH minus, addition of H plus, what happened? Addition of OH minus, what is going on? It is going to form this H plus and they form water molecule. Here what more? Acetic acid. Here what happened? OH minus is combined with H plus to form H2O. Here whenever, how to release this H plus mean this acetic acid. This acetic acid dissociate, it releases H plus ion. Whenever addition of OH minus to combine what more, this OH minus to this and to produce what more, water molecule and releases what more, acetate anion, acetate anion. Next sodium acetate, sodium acetate whenever dissociate it releases Na plus, Na plus and CH3COO minus. For this addition of H plus, addition of H plus, here what happened? This CH3COO minus is combining with this H plus and form acetic acid and forms acetic acid. This is the buffer action. Whenever H plus to release, you can add OH minus to produce water molecule. Whenever acetate ion is going to release, you can add H plus to produce acetic acid. This is the buffer action of buffer solutions. Buffer action of buffer solutions. And also once again I am repeating, Ask Engineering Academy, download the app from Google Play Store, and especially this coaching online classes for Ecet, Telangana and Andhra Pradesh people. Okay, thank you. Next video I am going to continue in the next class. Thank you.